Okay, we left on a bit of a cliffhanger dealing with runners in a race. Right, there are 8 runners. They are going to finish in one of 8 places, but they're not independent of each other. Right? 2 people can't both finish first. Also, one person can't finish first and third. Right? So this is not truly independent. We're going to have to work a little harder to get at dependent events, we'll say. For want of a better term, we'll call it dependent events. So whenever you're doing counting problems, we're going to usually ask ourselves 3 questions. Are the events in question independent of each other? If they are, then fundamental counting principle is going to bail you out. If they're not, you're going to have to start asking some harder questions. Does order matter? Does the order that I'm doing the arranging matter? And can the same selection be repeated? That's another question that gets asked. So, for instance, runners in a race, just because we're using that example right now, the order people finish in a race definitely matters. The selection can't be repeated because first place finisher guy cannot also be fourth or seventh. So here we would answer for runners in a race, yes, order matters, no selection cannot be repeated. But for dependent events, there are 4 big questions depending on how you answered those 2 questions. If there is no replacement, you're going to use one of these 2 equations. If order matters, you would use one of these 2 equations. If order matters and there is no replacement, you will use this equation. Just for reference, this one right here, this end of the R, is basically what we were just doing with the pins and the passwords. So we've kind of looked a little bit at this one. These 2, the NPR and the NCR, that's a C, I promise, are the other 2 big ones. That's the one we're going to look at in this series. This is going to be the one we're going to look at in the next series. And this one right here, I put up just for completeness sake. I'm not going to promise you this, but I'm pretty much going to promise you that we're not going to use this one in this class. It's just there for completeness sake. But let's worry just about runners in the race and see if we can figure out how this equation came to be. So before anyone crosses the finish line, how many configurations of first place finishers are there? Well, there's 8 guys or gals. One of them finishes first, so there's 8 ways that can happen. Okay, so stick with me here, see how it goes. Suppose that person, whoever it was, has finished. So independent of that, how many configurations for second place finishers are there? So independent, which is, again, kind of weird because it does depend on who finished first, right? But as independent as we can make it, how many different ways can there be second place finishers given that someone has already finished first? And in this case, there's only 7 remaining configurations, right? Given that the first guy is already finished, there's 7 people left, and one of those 7 people can finish second. So if we keep going, we can keep tracing this all the way through. Third place, there are only 6 people left in the race. One of those 6 will finish third. For the fourth place finish, one of the 5 remaining runners will finish fourth. And then 4 for fifth, 3 for sixth, seventh for seventh place, there's 2 left. And of course, once everyone but the last person is finished, that person can only finish last. Straightforward enough. So altogether, using what is essentially, in air quotes here, the fundamental counting principle, the number of configurations here is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Altogether, that is 40,320. Again, you might be able to get away with just typing this into some online thing, but this is the actual number. Also, just so you know, we can also write, and we will sometimes write 8 exclamation point or 8 factorial instead of 8 times 7 times 6 times 4 after there's just 1, because that's just a lot of writing. So this is 8 factorial, and we'll pick up with factorials in the next video. I will see you then.